Let's now learn how carboxylic acids react with bases. We just saw that if you place carboxylic acids in water, they can act as weak acids and they can lose a proton. When carboxylic acids are present with or reacted with, is what I'm trying to say, with strong bases, one of the things that happens is that in the presence of strong bases like sodium hydroxide or potassium hydroxides, what carboxylic acids do is that they form what are called carboxylate salts. Carboxylate salts are actually solid at room temperature and are usually soluble in water because they are going to be ionic compounds that now have elements from group 1A in the periodic table. And if we go back into our knowledge of solubility rules, anytime you have an ionic compound that contains sodium, lithium, potassium, rubidium, meaning cations from 1A, those molecules are soluble. So one way in which you have long chain carboxylic acids that are nonpolar, but you want them to solubilize them, you convert them into ionic salts when you react them with strong bases like sodium hydroxide or potassium hydroxide. A number of acid salts are important around the home, including soaps, but also there are some that are used as preservatives in food. You can see specifically in figure 10.20 that soap products enable us to keep ourselves and our homes clean, and this is an example of a carboxylate salt. We can see the general reaction on the right side of the slide, and what happens overall, since the carboxylic acid is going to be acting as a weak acid, the base is going to be acting as a base, specifically the hydroxide group in this ionic compound will be combining with the hydrogen in the carboxylic acid, and that's what forms the water. Once the hydrogen leaves the carboxylic acid, what happens is that the oxygen atom turns into an anion, and in order to stabilize it, the cation that was part of the strong base sits next to that oxygen that now is negatively charged. Let's actually do some predict the product examples from our in-class worksheet. We can observe in reaction 11 that we have a carboxylic acid combining with KOH. As we saw before, overall, what we see in this reaction is that the OH is going to combine with the hydrogen in the carboxylic acid. And when that combines, that is going to make water. Let me just highlight it so we know where the OH and the H came from. Next, if I'm trying to predict the products of what's going to happen to my carboxylic acid, I'm going to redraw my carboxylic acid, not including the hydrogen in the carboxylic acid. And then my oxygen is going to be negatively charged. The potassium, which is the leftover cation that is formed, is going to be written next to the oxygen anion that is going to be part of the carboxylate salt. So this is the product of the following reaction. Let's now predict the product for reaction 12. Similarly to what we saw in reaction 11, the OH in my base will be bonding to the hydrogen in the carboxylic acid. And what happens is that that forms water. Next, what we have is that overall, our oxygen in the carboxylic acid becomes negatively charged. And in this case, since the cation in the ionic base is sodium, that is going to sit next to the oxygen atom that became negatively charged once the hydrogen left to combine with the OH in the base. And this is the carboxylate salt that is produced from the reaction on 12. Now we're going to proceed to go over the nomenclature of esters. Esters, as we're going to see in a moment, it is a functional group that actually it is produced from combining a carboxylic acid and an alcohol. And knowing that that is how esters are going to be formed, that's going to help us how to name them. That's why at times esters, since they are formed from carboxylic acids, they are called carboxylic esters. Amides, similar to esters, are going to be produced from carboxylic acids. But in order to make an amide, which an amide is when we have a C double bond O connected to nitrogen, we are going to be making them by combining a carboxylic acid and an amine. Let's now learn how we name at least the esters. In this class, we are not going to go over the nomenclature for amides. In order to know how to name esters, let's understand that, as I just mentioned, esters are carboxylic acid derivatives because they are formed from the combination of a carboxylic acid and an alcohol. So, for example, we see here the following ester. This has a CH3 connected to a C double bond O, single bonded to oxygen, and that is bonded to CH3. If we create a division line between the C double bond O and the single bond oxygen, we can observe that this area of the molecule corresponds to the alcohol, and the C double bond O with the rest of the molecule is what corresponds to the carboxylic acid in the ester. And that's what's going to help us to name them. Let me do the examples below. You have the 3 steps on the left side of the slide that is going to help you to understand how do we name esters. In the following ester, I'm going to write a line in between the C double bond O and the single bond oxygen. And what happens overall is that in this ester, I know that the area of the molecule to the left in this case, because that's where the single bond oxygen is, came from the alcohol. So the alcohol that looks like this, it was the one utilized to make this ester. The C double bond O, meaning this area of the molecule and the rest, that came from the carboxylic acid. So I'm going to write OH here, and then I'm going to count the carbons: 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons. 1, 2, 3, 4, 5. So I can actually write the names of the alcohols and the carboxylic acid. The alcohol is ethanol, and the carboxylic acid, since there are 5 carbons, is going to be pentanoic acid. Once I have determined, okay, The alcohol and the carboxylic acid that made my ester, the way that I name the ester is in the following way. The first word in my ester name is going to be coming from the alcohol. And specifically, what I'm going to write is the alkyl chain where the alcohol came from. One way to do it is to replace, specifically in the alcohol name, the ANOL and replace it by YL. What I mean by that is that in this alcohol, I have one carbon, two carbons, so that is an ethyl group. So that's the first word in my ester, ethyl. Next, in a separate word, what I'm going to do is that I'm going to take the carboxylic acid name and I'm going to take away the ic acid and replace it by ATE. So the suffix goes from ic acid to ATE. So the second word to name this ester is going to be pentanoate. The name of this ester is ethyl pentanoate. Let's look at the next example. Here we have an ester. I'm going to draw a line in between the carbonyl group and the single bond oxygen. Whatever is connected to the single bond oxygen, that came from the alcohol. So in this ester, this was the alcohol that was combined with the following carboxylic acid. Because remember, as I just illustrated, this C double bond O with the rest of the molecule, when you connect this carbon to OH, that's your carboxylic acid. So now I proceed to name the two components that made that ester. The molecule on the left is benzoic acid. The molecule on the right, that is 1-propanol. Okay? So, as I mentioned before, the first word is going to be coming from the alcohol. So I'm going to replace the ANOL with YL. So for this molecule, this is going to be 1-propyl, or in other words, propyl. And then the benzoic acid, I'm going to replace specifically the ic acid with ATE. So the second word for naming this ester is going to be benzoate. And that's how you name esters. Let's now go over the reactions for esters and amides. In naming esters, we already explained that esters are going to be formed by combining alcohols and carboxylic acids. Let's formally introduce the reaction. Esterification is the reaction by which a carboxylic acid combines with an alcohol or a phenol group in the presence of acid and heat to make an ester. We can observe that in this process overall is also a dehydration reaction because water is produced. When an amide is going to be formed, this reaction is called amidation. The reaction for an amide, specifically between a carboxylic acid and an amine, produces a salt, not an amide, unless it's heated. Now, a better way to produce amides is by specifically taking what is called an carboxylic acid chloride, which means a functional group in which you have a carbonyl, into one side of the molecule, you have a chlorine. When you react this specifically with primary or secondary amines, or even ammonia, which ammonia is NH3, that is going to produce an amide. Along with that, we are going to make HCl as a byproduct of the reaction. Let's do some practice problems in the synthesis of esters and amides. These problems are from the in-class worksheet. Let's understand that for the in-class worksheet, reactions 13 and 14 are esterification reactions. And the reason why I know that these are esterification reactions is because I have carboxylic acid and an alcohol. The same thing for 14. We have a carboxylic acid and an alcohol. In the case of reactions 18 and 16, those are going to be amidation reactions. The reason why these are amidation reactions is because I have an acid chloride combined with a primary amine. In the case of 16, remember that specifically if you have a carboxylic acid and an amine and you heat them, it's going to form an amide. It's not the most elegant or preferred form, but the amide will form. So how do I draw the product of esterification reactions or amidation reactions? Let's proceed. In reaction 13, the way that I write my ester is that I'm going to draw my molecule up until the carboxylic acid. That means that this carboxylic acid, which is propanoic acid, I'm going to draw the double bond to oxygen, and then I'm going to draw whatever was on the R group of the molecule. So if I use my highlighter, what I'm drawing is this part of the molecule right here. Whenever this reaction is performed, the OH combines with the H of the alcohol, and that's what forms water. Next, I'm going to bond my carbonyl group to the oxygen and the alcohol. So to highlight this oxygen is the one that I see here. And then I'm going to write the rest of the molecule, which in this case is going to be one carbon, and then two carbons. And at this end, I have this part of the molecule. So understand that this comes from this is what I drew here. And that's how you write the ester that comes from the combination of those two compounds, the carboxylic acid and the alcohol. Let's do example 14. In example 14, we again have a carboxylic acid and an alcohol. In this molecule, remember that the OH goes away with the H in the alcohol, and that's what forms water. Next, I'm going to redraw my carbonyl, C double bond O, with the group that is attached to it. Let me highlight it. C double bond O with the two groups that are there. And then I'm going to connect that carbonyl to the oxygen in the alcohol, which that is this atom. And I'm going to draw everything that is attached to that oxygen. In this case, I have a carbon with a CH3, another carbon, another carbon. So to follow the highlighted atoms, this is this carbon, and then has this groups. And that's how we draw the ester that comes from that carboxylic acid and that alcohol.